Good afternoon, everyone. So my name is Rui. I came from the GeneT Institute at the University of Coimbra, and it is my pleasure to present you the SafeAlleleSCA for the first time. So polyglutamine spinocerebellar ataxias, also known as polyQ-SCAs, are a group of 6 autosomal dominant neurodegenerative diseases caused by abnormal CAG repeat expansion in one allele in the specific gene. So this mutant allele leads to a toxic protein, and this toxic protein damage neurons, particularly in the cerebellum. So due to that, the patients usually present several symptoms, problems in balance, motor coordination, and others, leading to death. So, although individually rare, altogether this group of disorders reach up to 200,000 patients worldwide, and there is no therapy for this group of diseases. Of course, some of therapeutic approaches are now under development, but unfortunately all of them target both alleles, the mutant as well as the normal allele. So in our vision, this can be a big problem. So in our case, our approach named SafeAlleleSCA, we already optimize and test different constructs and selects the best artificial microRNAs that can specifically target the single nucleotide polymorphisms or SNPs that co-segregates with the mutant alleles. So this leads to a specific silence of the mutant messenger RNA, preserving the production of the normal and or wild-type protein. So we are creating here something new, something safer and more precise to treat dominant neurodegenerative diseases. So regarding preclinical studies, firstly, we developed our delivery strategy. Basically, we combine the use of a non-pathogenic virus, the AAV9, with intracisterna magna administration. And as you can appreciate here, upon a single intracisterna magna administration of AAV9, we transduce the old brain here with a green color. So next we test this strategy in our lead clinical indication, spinocerebellar ataxia type 3. Particularly, we test in a transgenic mouse model of SCA3. And in this specific polyQ-SCA is characterized by the accumulation of mutant ataxin-3 protein aggregates in the cerebellum. And as you can see here, upon a single ICM injection of AAV9 encoding for this specific artificial microRNA targeting the mutant allele, we statistically significant decrease the levels of ataxin-3 aggregates by 70%. So more importantly, as you can see here, so the treated animals with the SafeAlleleSCA demonstrate significantly better motor coordination and balance. And these results were really important for us because we are using here a severely impaired transgenic animal model of SCA3. So we move forward and we already test this strategy in non-human primates. So basically, we confirm that the ICM administration of SafeAlleleSCA in adult non-human primates can reach and transduce the CNS and present a dose-dependent expression without toxicity. Of course, we already achieved important steps. We are now consolidating our therapeutic lead, and we are planning now moving forward to GMP and GLP tox studies. But something important, apart from the SCA3 program, we are now testing in our lab the same strategy in other polyQ-SCAs like SCA7 and SCA1. So in conclusion, SafeAlleleSCA is a precise and safe therapy based on the single and minimal invasive injection, is patent protected. As already, it's a strong preclinical proof of concept in rodents and non-human primates, and it is a scalable platform not only for other polyQ-SCAs, but other dominant neurodegenerative diseases. So then that's all, and thank you very much for your attention.